Seventh one. If the elements of this matrix A are real and positive and distinct. Determinant. Have you done this question? It doesn't make any difference whether you do transpose of a determinant or no transpose. Hardly makes any difference. To remove that, you talk about only A plus A transpose determinant value. And it is being given as 0. Okay. So what do? Take any random A, B, C, D or P, Q, R, S. One matrix you take. With A, B, C, D positive. And do transpose of it. So A, C, B, D. And add them up. 2A, B plus C, D plus C, 2D. Do the determinant value and make it 0. 4AD minus B plus C whole square equal to 0. 4AD minus B square, or write it B plus C equal to under root 2AD. Am I right? B plus C is equal to 2 root AD, or B plus C over 2 is root AD. Something you can recall from this place: when they are real and positive and distinct, you can apply AMGM approach. So comes up B plus C over 2 is greater than root BC, not equal to, because they are distinct. So B plus C over 2 is greater than root BC. So from this place, B plus C over 2 is root AD. Root AD is greater than root BC. I remove AD greater than BC. I got it. Got it? AD greater than BC. So AD greater than BC means whatever is being asked. Determinant A is nothing but AD minus BC. AD minus BC becomes positive. Am I clear? So determinant A is positive. First answer is correct. Second answer is wrong. Equal to can't be done. A minus A transpose, you can calculate. This is nothing but determinant A square, which is already positive, so it will be automatically there. A minus A transpose, you do subtraction. This becomes 0, becomes minus C, becomes minus C, C minus B. This becomes 0. You got B minus C whole square, which is also positive. This answer is also correct. Clear? Go to 8th one. So you have U, V, W are the unit vectors. It's pretty easy question. I think you have done it. No. All are correct. Shall I do it or we can skip? Shall I do it? No or yes? This one. Paragraph. A white balls, B black balls. A balls are drawn and laid aside, their color not noted. Then one more ball is being drawn. Probably that the ball drawn is white. Need to do? Or I can skip? Tell me. Shall I do it? You want me to do? This one? Your voice is not clear. Is it to be done or I should skip? Answer. Answer is, I think, 1. Then go to this question. 12th. The answer is, I guess, a complete expression is there. 3y plus 4z plus minus 5 root 3x equals 0. This is answer. This is to be done by easy way. Just a family of planes concept you can apply. But they are saying this plane is rotated about the line of intersection with the plane this. So family of plane passing through the intersection of these two is there, making an angle of 60 degree with the given this plane. So you write 3y plus 4z plus lambda times x equals 0. P1 plus lambda P2. Okay. And now take this plane and angle between them is 60. So cos 60 is equal to 0 plus 9 plus 16 over under root lambda square plus 25 and root 25. This is nothing but 1 over 2. You have lambda square plus 25 under the root 5 go on. You have lambda square plus 25 is nothing but 10. Under the mod is there, right? Where I did the squaring. Okay. This is 100 being formed. Squaring done. So lambda square is 75 plus minus 3. This is clear. Understood? Let's deal with this now. On a chessboard, two squares are chosen. Like this. On a chessboard, you know very well. If the probability that they have a side in common is 1 over p, you want to know p over 9. Sample space is 64C2 because it should be mentioned over there that the squares chosen of 1:1 only. They should specify. Otherwise, the square can be of this type also, na? 2 by 2 square can also be there. So they should mention it. The squares chosen are of 1:1. The smallest ones are being talked about. That statement is missing, which you should get the clarity. You should know that. So this is I'm doing on the basis of that only 64C2, and I want there should be exactly one side common. So in a row, I know that there should be 7 pairs, which can form like this: 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8. So one row 7, I go like this 8 times. So 56 I'll get it horizontally. Similarly, 56 I'll get it vertically. I'll get 112. I'll get 112 P1. Any one I should take it. This is 112 over 64 into 63. That you have to solve. 16 sevens are 16 fours are 2 are 7 nines are. So 1 over 18. So P becomes 18. 18 over 2, 9 is 2. The answer is 2 in this case. You understood? Moving to this now, let S be the set which contains all possible values of L, M, N, P, Q, R for which this is a non-singular idempotent matrix. Idempotent stands for this. Should be non-singular. Understand, if I multiply A inverse on both the sides, it forms I. This is I. A is equal to I. It should be an identity matrix then. Idempotent and non-singular, it should be identity. So compare it. L square minus 3 should be 1. M square minus 8 should be 1. N square minus 15 should be 1. P should be 0. R should be 0. Q should be 0. From this place, L comes out to be plus minus 2. From this place, M comes out to be plus minus 3. From this place, N comes out to be plus minus 4. What they want, sum of all the elements of this. Possible values are this, 0, 0, 0, 0. Answer is 0. Clear? Going with the next. Each question contains, in this case, are of the two elements. Okay. A is an idempotent matrix. I is the identity matrix of the same order than the value of n for which this is going to happen. This question is wrong in the sense of it. Since it is a matrix, so it is not looking like matrix. So you should have A over here. Mark this thing as incorrect question. It is 127A. Matrix dimensionally should be equal to a matrix only. It cannot be 127, it should be 127A. So nothing else, you just understand this. When you have A square equals A, right? Idempotent. If I do cube, you get A square, which is nothing but A again. If I multiply A again, it should form A cube, na? A cube equal to A square. A square is nothing but A. If I do A power 4, it is A cube. A cube is nothing but A. Means in idempotent, every raised to the power remains same. What I'll do, A plus I power n, I'll open expand it like binomial. So I get NC0 plus NC1A plus NC2A square becomes A. NC3 A cube becomes A. NCN A. Am I clear? Take NC0 as 1 and then A common. This becomes 2 raised to the power n minus 1. This 1 is nothing but I. Because I is written na. I mapped with I. This should mapped with 127. So 2 power n is 128. So the answer is 7. You understood? Going to the next one. I'm clearing it off. Next one, 1 over I minus A. Inverse means this, na? I plus A square up to A7. Take I minus A on that side. Here you cannot apply this idempotent concept. This is not applicable. This is only for first part, not for B. So I take I minus A on that side and this is 1 means I only. I equals I minus A multiplied by I plus A square up to A power 7. Okay. You understand there is some algebraic part. You must be knowing that 1 plus x square up to x power 10, let us suppose. How many terms are there? How many terms are there? 11 terms. So if I say 11 terms are there, I write its answer as, means it is vanishing over there, A over 1 minus R. Ultimately, it comes as A into TP concept. You understand? 1 minus x power 11 is nothing but 1 minus x into this whole. Same thing type thing is forming over here. Up to 11 terms are there into 1 minus x is forming 1 minus x11. 7 terms not there, 0 it is being beginning, so it is 8 terms are there. When you multiply with this, it will get I minus a power 8. They are giving equal to I. Your a power 8 should be 0 for null matrix to balance the equation. Your n should be 8. You got it? Next. It's very important and easy. Aij equals I plus j multiplied by I minus j. A is a singular if order of matrix is. You understand? If I take any matrix 3 cross 3 or 2 cross 2 or 5 cross 4 or 5 cross 5 or 4 cross 4. So what I want to say, let us suppose 3 cross 3 if I take. First term becomes 0, I equal to j, I equal to j, I equal to j. This is the matrix I am writing. Second element is 1 plus 2 and this is 1 minus 2. This is minus 3. A1 2. A2 1 becomes 3. A1 3 becomes minus 6. It will become 6. It will become A2 3 becomes 5. 2 plus 3 5 minus 5 and this becomes 5. What do you see? It is a skew symmetric matrix. And the best part to understand from the skew symmetric is that any odd order skew symmetric matrix determinant value is 0. So what do you conclude from this place? What do you conclude from this place? That odd order should be singular. So your answer should be 1 to many, 7 and 9. Clear? Skew symmetric, write down the statement, odd order skew symmetric matrix, determinant value always 0. Skew symmetric, odd order matrix, determinant value always 0. This is over. 7 and 9 is the answer. Moving to the next. Non-singular matrix A is symmetric. Could be any matrix. Show that A inverse is also symmetric. Obviously, you know that when a matrix is symmetric, A transpose should be equal to A. When you do A transpose inverse, it is nothing but A inverse transpose. Makes no difference. So it is again correct. We don't have to show. It is just written absurd thing. Then order of A matrix. A matrix can be of any order. It is not having any role of setting the order for non-singular symmetric. Symmetric, any order can be possible. Your all answers are correct. So any order symmetric matrix always exists of non-singular type.